Hello everyone. So today we are going to see a session for SOA and enterprise integration. In this session, as part of this session, we will be looking at and learning what a service-oriented architecture is, what are the different components of service-oriented architecture, what are the advantages, and why do we really need to go for service-oriented architecture in enterprise application development. What does it solve? What are the problems does it solve? And then we will look at the enterprise integration, one of the key things which is like in the past decade or so, enterprise integration is a buzzword, and this has come to the rescue of multiple projects and integration wherein enterprises which have their systems developed in legacy systems, and then right now they are coming up with a new technology. So how do we integrate all these legacy systems with the new applications that are getting developed, and how do these disparate applications which talk different protocols and different talk different languages and built on different platforms, how these applications interact with one another. So these are the two, like SOA and enterprise integration go hand in hand. Enterprise integration, like the solutions that are present right now as part of the enterprise integration is greatly greatly benefited from the service-oriented architecture. So by following service-oriented architecture, we are able to make use of the tools that are available for enterprise integration, and then really make our applications communicate with each other in a very smooth and scalable and maintainable manner. So let's get started. So as part of the agenda, we'll be looking at what a service-oriented architecture means. We'll look at the definition, and we'll see the main backbone of the service-oriented architecture, that is a service, and the practical sense of it, the service orchestration. So what really happens in the applications when we follow a service-oriented thing is the service orchestration. So we look at what a service orchestration means along with an example as well. The next we'll jump on to the enterprise integration, the key topic. Enterprise integration is like one implementation of SOA. So we are integrating the enterprise applications using ESBs. This session will focus mostly on the open source ESB, specifically on the Mule ESB. Today we'll not be looking at it, but on a general terms we'll be looking at what are the challenges that we face in the enterprise integration, and how does ESB come to help us, and how service-oriented architecture plays a key role there, and what are the advantages of using an ESB there. So these are the different things that we will be looking at. So yeah, service-oriented architecture, there are multiple definitions of that is given by different organizations, different key people in the technology space. So for that you can quickly have a read, like it's all subjective, it's all on the interpretation. So from my side, when I look at service-oriented architecture, what I see is it's a when I say service-oriented architecture, it's an architectural pattern. It's a way of building enterprise application, nothing more than that. It's just a design pattern wherein we say the systems needs to be designed and implemented and architected in this way, so that we solve our enterprise like we will create our applications in such a way to solve all our enterprise needs. So that's what it puts forth. A way to develop the software. So there were multiple ways in the earlier. So we had monolithic softwares created, in the sense all the functionalities were kept inside the same application, and then we did modularize the applications. Then came the client-server architecture, then the distributed architecture, wherein we were able to move parts of the functionalities to different distributed in different systems, and then we were able to integrate them and work upon, and that gave rise to multiple problems of integration and availability, all scalability, maintainability, all these problems. So the latest architecture that is come up as a service-oriented architecture, and this is looking at a long term, this is going to stand the test of time. So the key to developing any application, right from a small application to the enterprise level big applications, the key is loose coupling. That's the major, any software concept, starting from object-oriented principles to any concept in software engineering. which the key concept that comes around is the loose coupling. So all the concepts that are developed is mainly coming towards saying keep the applications, keep the systems loosely coupled from one another. Even within the application, keep the modules loosely coupled. The reason to keep it loosely coupled is whenever there is a change, when we have an application, there are different modules, there are different components, and we always want all of them to talk to each other. Otherwise, there is no use of these components. So when they talk with each other, we should keep the associations as minimal as possible, meaning most of the implementation details of one component should be hidden from the other. That way, we loosely couple the systems, we loosely couple the modules, we loosely couple the applications. When one application has little knowledge on how the other application is developed and is going to behave, and it just only is concerned with what it is going to send and receive from each other, then we are in a good space. But once the applications are tightly coupled or it depends on the other application, then it's going to be difficult. So one key thing that service-oriented architecture provides is that it enables us to loosely couple interoperable services by the virtue of just using this architecture. So that's one key thing that we get out of SOA. And practical terms, when we go and try to build the, when we go ahead and try to put the architecture in the practical terms, we build and implement the set of applications. How does it work? It works based on what we call as service orchestration. So this is the main backbone, or this is the main theme behind how an SOA works. This is how an SOA works. SOA system works basically. So we will look at service orchestration in a bit. Before that, since we are talking about always service-oriented architecture, the key word is service here. What exactly do we mean by a service? What does it compose of? When do we call a service a service? So we'll look at that. Again, there are multiple, service is not a new concept or something new that came up with the service-oriented architecture. It has been there for ages. The only thing is definition and the way it is being developed and architected and the design. So basically, service is nothing but it's a self-contained, reusable piece of software. That's it. So it's going to be loosely coupled. It's going to be meaning it's going to be self-contained. So it's just like it follows the same principle of developing a class. A class should be self-contained. Similarly, a service, whatever you are providing, that should be unique, that should be self-contained. Self-contained in the sense it's not that it will not talk to others, but just that the purpose of the service is self-contained. It should be uniquely identified, and by that, when we have this loose couple nature, we can reuse it in various other, reuse it as part of different operations in a business. So why do we create services? At last we want to solve some business process or the other. So there might be a case wherein multiple business processes in your enterprise wants a particular service. For example, let's say you have an employee search service. So you want this employee search service as part of your hiring process, your part of your salary processing process, part of many different processes wherein you want the employee to be searched. So in that case, we would develop an employee search, which is a unique service, which has a clear description of what it needs to do, and we would be able to develop it in a self-contained manner wherein other services, regardless of what operation they belong to, regardless of what application they belong to, or regardless of what processes they belong to, they would be able to communicate with the service, send message, receive message, and they will be able to do their task. So we achieve reusability, we achieve loose coupling, and this is how a service is going to be developed. So this is basically the definition of what a service means, and that is the backbone of service-oriented architecture, wherein all the applications, all the systems that we are going to develop is going to be in the form of a service. So we are going to provide some service to different systems. So different systems talk to each other on services. There are different tools to create the services. We can go for the Java web services. IBM has its own web services. So web service is the implementation part of it. We have the SOAP, we have the REST, and all the tools that we have to create the web services. So in whichever way you expose a service, basically it is just a self-contained reusable unit of software which could execute a particular task, and which can be invoked from multiple systems. And the key thing is it's platform agnostic. So it should be we should be able to invoke this service from different platforms which are developed systems in different platforms, and which are developed in different languages and which talk different protocols. So that's the backbone. We will see how do we make that happen. How do we make a different system developed in a different language, or which is hosted on a different platform. How does it talk with a service which is developed on a very different language. We'll see how do we actually do that and all. But just understand, it can do all that stuff. Now coming on to service orchestration. Service orchestration here, what we mean by service orchestration is that it's the, at last we, as I said, services at last needs to interact with other services for a particular, to implement a particular business operation or a business process. So herein, so when we have a business process, it might interact with different systems for the process to be executed. It might call different services which are, it might call different systems and services developed in different platforms and languages. So that's the orchestration. So orchestration is nothing but it's the process of integrating two or more applications together to automate a process, meaning it's a process of making two or more applications or services talk to each other to solve a business problem. So that's what is orchestration all about. We are going to make one or more services talk to each other to solve a particular business process. And here the keyword is integrating two or more applications are services. Service is also a keyword. The example that we are seeing here is the insurance claim application. We have a client application, and that's going to perform an insurance claim operation. So an insurance claim has come, so it needs to perform the claims adjudication, claims processing, let's say. So it needs to do that task. So the client app is the client side of it. So this is the back end or the service side of it. So to do this claims processing activity, the server needs 4 different services to be, it needs 4 different services to be executed to perform this particular claims processing activity. One is the customer service, which checks the customer details and all that. Then there is a claims validator service, which is going to check whether the incoming claim is a valid claim or not against a set of rules that are developed. And there is this balance status service, wherein it's going to check the credit balance of a particular, of the customer, whoever is claiming this, whether he is eligible, whether he has the balance, what is his insurance history, all that, whether he is eligible to do that. And if after all that, if it is all fine, then we are going to have this debit balance service, which is going to debit the amount in his account. So this is what. So all these 4 services are built without the knowledge of other services. So that's why I call them loosely coupled and self-contained. So this customer service can be used in as part of any process wherein a customer service is required. And the claim validity as the same, balance as the same. So we are going to implement it using some SOA based integration platform. It might be an ESB, it might be the application is architected in such a way that it is hosted in a particular platform like Oracle SOA 11G or some SOA vendor provided stuff, and wherein we are hosting all our services. Okay, so I think you understood what a service orchestration means. Let's move on. Now coming to enterprise integration, the one that I love. So enterprise application integration. So it's generally called enterprise application integration, EAI. This is the latest buzzword in the industry, and lots of tools and lots of solutions are coming up, and it's a hot thing in the market as of today. What does it say? So at last, it's the same thing. This is also not a new concept. This is the latest solution that has been available for a long-standing problem. What's the problem? Again, the problem is how do we make systems interact, enterprise systems interact, which are developed in different platforms and different technologies. That's the same problem. How do we make these systems talk to each other? How do we integrate it? How do we make them interoperable so that we solve a particular enterprise problem? See, as the days go, as the years and decades pass on, we would have developed lots of applications in our enterprise, sometimes monolithic, sometimes redundant applications. So these applications would be there, which and at certain point we want this application to talk to some new application that is developed in a very new technology, and we suddenly realize that the old application can't talk its language. So how do we do that? But we can't migrate the whole logic that is there in a legacy application or an old application onto a new application for various reasons. One might be you don't have the money to do it. The other might be that there is plenty of logic inside it and you don't have the business knowledge or the people who have that business knowledge to migrate that application from one technology to another. And let's face it, moving an application from one technology to another is no easy task. So we need to make applications talk to each other regardless of what their platforms are, what their languages are, and what their protocols are. So that's the key goal of enterprise application integration, to make applications interoperable. And when we say applications, we mean the disparate systems that are developed in different protocols and languages that form the enterprise IT. As I said, any enterprise is going to consist of multiple systems, and when the distributed environment comes into picture, we have additional layers of problem. So how do we, so what is the solution? So we have this web service, right? So we have this web service, we have the services. So what's a distinction I'm just going to bring out? So even if we follow the service-oriented architecture and we have the web services developed, and without this enterprise integration technique or the tools that provide this enterprise application integration, so how do we make applications talk to each other? Now let's consider these are the 6 applications that we have, 1, 2, 3, 4, 5, 6, and we need let's say only at the starting we had only application 1 and application 4, and these 2 applications were talking to each other without any problem. Now later on we introduced, let's say, application 5, and application 1 needed to talk to application 5, so we developed another link here. So we developed some communication channel here, some communication channel here, and then later on we introduced application 2, which needed to talk to application 4 and application 5 as well. So we developed that, and we had application 3 which is talking to application 2 alone. Then we developed application 6 which is talking to application 1. So this is how we have connected the applications. This way of making applications talk to each other is called point-to-point communication. So in this way what we have done is tightly coupled one application to the other, because if one application changes, the other application definitely do need to change if they have to talk to each other going forward as well. So let's say application 2 changes. So if application 2 changes, then application 3 needs to be changed, application 5 needs to be changed, and application 4 needs to be changed. So as and when any application changes, all the other applications that talk to it also needs to be changed. And imagine if there are multiple applications and then multiple connections to each other. So we are going to have a scenario wherein we are constantly changing one application or the other, and it might lead to a chain reaction as well, wherein all the applications needs to be touched. So this way of communication is okay if you have finite number of systems and a limited number of systems, and if it's a small applications, then you will be able to live with it. But when we are talking about an enterprise, a very large enterprise wherein you have thousands of applications, and those applications are huge and distributed, then you would not be able to like survive long enough by having point-to-point communications. So let's define what a point-to-point communication is. In a point-to-point integration model, a connector is developed for each set of applications or systems that needs to communicate with each other. So we are saying that in the point-to-point integration model, for an application to talk to another application, we need to define some sort of connector that might be the web service interface that we are developing, so that these two applications can talk to each other. This connector handles all the data transformation. So what does data transformation mean? The data needs to be transferred from one format to the other format, the data format that this expects. So if it's a mainframe system, so it might be expecting a copybook format of data, wherein a Java system might be expecting a Java object. So we need to convert these objects from one another and try to bring them onto the same platform. That's what web service does. It brings them to a text-based XML format, or in the case of REST, we can also do it in XML or JSON or whatever format that we want. And then integration, as usual, you're making them talk to each other, and any other service that is required for the communication of these two disparate systems. So the challenges, as I mentioned, so this sort of communication, this sort of integration between applications is not maintainable, first of all, because it's prone to changes. It's the cost of maintaining is too high, and it's no way scalable. So if you add 10 more applications, then you're going to be in a mess. Soon you will not know which application is talking to what and which application gets affected if I touch one part of the some application. And when we go for this mission critical application, in cases of mission critical applications, we want high availability. We want what do we call that? We want a fault tolerant. We want, when the service goes down or something, we want the system to be notified that a particular service is down, so that we would be able to take corrective measures. We would be able to log the errors. So error handling becomes one key thing. The availability of a service becomes a key thing in the case of mission critical applications. So this is not possible when we are directly integrating the applications to each other, wherein we won't have a channel for an application to notify the other one when it is down or when it is going under maintenance and all that. So these are all the key challenges that we face in a point-to-point communication. So here comes the solution. We have the enterprise service bus, which comes to save us and solve all these problems of point-to-point communication. What does enterprise service bus do to us? So it forms a layer in between, and it allows the applications to communicate with the enterprise service bus in the form of messages. So that a message, so the data is going to be put in the form of a message, and that message is going to be consumed by the different application, whichever application. So every application is going to talk to each other, and the bus is going to take care of talking to different applications. So this enterprise service bus is capable of talking in different languages, talking to different protocols, all sorts of things this enterprise service bus will be able to handle. So your application doesn't have to worry about whether it is talking to a mainframe application or whether it is talking to both a mainframe application or .NET application, a Java application, or some technology which is very new. So you don't have to worry while developing what sort of applications you are going to interact with. You can put your energy and mind only on your business logic, on the technology, on the platform, on the data format that you're working, and not worry on the integration stuff. The enterprise service bus is going to take care of all the integration requirements for you, and you are the pressure on you to develop an application which can be interoperable with other applications is taken away by introducing the enterprise service bus. So the bus takes care of making that possible. So bus is responsible for data transformation, it is responsible for finding whether an enterprise service is available, it is responsible for security, it is responsible for routing it to the appropriate destination application. So it has got various capabilities and features, and moreover, it supports almost all the enterprise protocols and the data formats that are available. So you don't have to worry about it. You just have to plug your application into the bus, and rest the bus takes care of. So this is the and this architecture uh, feeds upon the service-oriented architecture. So when you have your applications developed in the form of services which follow the service-oriented architecture, enterprise service bus can really add on to the advantage of making these applications talk to each other in a very smooth manner. So this is how it works, and let's see what are given here. Enterprise service bus architecture is the latest solution. That's fine. It solves the point-to-point communication. So the other advantage is one application changes, let's say, none of the other applications that talk to, let's say application 6 is talked to by all the other five applications. But when application 6 changes, none of these applications need to change. They will not even know that application 6 has changed, because they are talking to a common thing called a service bus. So only the changes happening at the enterprise service bus level, and not to any of the applications. They will not even know that these applications have changed. So by this way, we reduce the cost of maintenance. We don't worry about the integration stuff while development. We can develop loosely coupled applications following the service-oriented architecture. We can make communication possible. We can handle the security here. The data transformation is handled in the enterprise service bus instead of in individual connectors that we created in the point-to-point communication for the applications that we created. So all these stuff the enterprise service bus takes care of. Basically, it decouples the applications from one another, the same point that we come to, the loose coupling. And as I said, an ESB is capable of communicating using various protocols and different data formats. So these are some of the features of ESB. Location transparency, which means it can be located anywhere, and the service which is going to talk to it will not worry upon finding it. It's just going to assume that the service that it wants to talk to is available, and enterprise service bus takes care of communicating with the destination service. And transformation, so data transformation, so it needs to change the data from one format to the other. Same way protocol. It might be talking to from an HTTP protocol to some other mainframe protocol or something else, and then you have a JMS protocol or something else like that, and then you have the routing feature. So you want to, when a message comes from one application, there might be dynamic instructions that message should be routed based on the message to different destinations. That service bus will be able to take care of. You would be able to monitor and administrate all the services that are connected or plugged into the enterprise service bus, thereby notifying the other applications that when a particular service is down or how it is doing, what is the performance. You would be able to monitor everything in a centralized location. That's the service bus. And we would be able to implement security, not only the security of talking to the enterprise service bus, also the security with the end application. Why do we need the ESB? We already saw all the things. One is it's a lightweight thing. So the actual functionality is developed within the services. It's just going to host, route, and then transform the messages and all that. And it is highly accommodative. When we say accommodative, it is able to accommodate multiple protocols and different languages. Whatever a new service comes up with, we don't have to worry about whether that service can be integrated with other services. So when we are developing anything new, you can be rest assured that your application would be able to integrated with other applications. You never have to worry about it, and it's going to be scalable and distributable as well. And then you have and the ESBs are SOA friendly, and it's incremental adoption, meaning we don't have to change our whole enterprise to everything here. So we can first get the ESB layer out, and then slowly one by one we can change the applications to follow the SOA architecture and then plug into ESB and then integrate with the other applications. We can slowly move from one layer of the applications to the other instead of going and spending millions of dollars and trying to change your enterprise top down in a single go. That way you would not be able to do it. And finally, we'll see what are the SOA advantages. As I said, the applications are loosely coupled, location transparency again. So the service can be located regardless of where it is hosted. And reusability, key thing, improved testability. Since it is loosely coupled, it can be tested separately and thoroughly. And high availability, since it's all services, it can be hosted separately in different clusters of the servers, and we can have distributedly enabled it. So the main thing for availability is always redundancy. So we need to have the thing hosted redundantly many times, and that can be done via the clusters. And since it's all loosely coupled, we can do that very easily without worrying about how big the application I'm going to host in this particular cluster. And then scalability, as always, since it's it has got a unique task to do, that particular service can be scaled up. Also, the scalability in terms of talking to the other applications, it can communicate with any number of applications, and a particular service can be consumed by any number of applications as well. So these are all the advantages of SOA, and this is what I had. Thank you guys for listening. Thank you.